Alright, we're going to look at solving cubic equations graphically. So just like with a quadratic equation, we first need to set this equation equal to 0. So this is a third degree polynomial, okay, because this is the highest exponent, which means the parent function would be y equals x cubed. And that parent looks like this. Okay, so on the left side, the function's going down. On the right side, the function is going up. That's called end behavior. Alright, so we want to set this equal to 0. So notice my x cubed is negative, so I'm going to go ahead and move it over here. I like having my leading coefficient being positive. So I'll subtract the 3x on both sides. Okay, now I have my 0. So I have x cubed plus 2x squared, and we always order them descending. So highest exponent first, that's the degree, then the next highest, and so on. And our constant always goes on the end if there is a constant. Okay, so we're solving this graphically. So first thing we're going to do here is we're going to turn our calculators on. Press the on button. New document. No, we're not going to save any unsaved documents. Okay, go down to graphs. And we're going to plug this in. So we have x caret. Now to get the caret, it's over here. Okay, x caret 3. And then I have to notice the cursor is up with the 3, so I have to arrow over to get it out of the exponent. Plus 2x minus 3. Whoops, I messed up. I need my square. So going back over here, I'm going to press the square button, which is right below here, the trig. Press the square button to get my square in there. Arrow over. Okay, 3x and minus 5. Uh-oh. What happened? Okay, so I'm going to go ahead and double click the center, I believe. And that will let me edit it. So 3x minus 5. I must have accidentally hit enter. Now we're going to press enter. Notice, just like the parent, the end behavior is the same. On the left, it's going down, and on the right, it's going up, just like the parent. And that happens when your leading coefficient is positive. If it was negative, it would reflect. Okay? So anyway, back to the problem. We want to find the solutions, because it says solving. So let me remind you where the solutions are located. They're located on the x-axis. So notice the degree of the polynomial is 3. That means there's going to be 3 solutions. So here they are, 1, 2, 3. Those 3 roots, or x-intercepts, or zeros, are the solutions. So to use our calculator to get those solutions, we're going to go to Menu. Okay, we're going to go down here to Analyze Graph. Arrow to the right. And we want to find zeros, number 1. Okay, so it says lower bound. So let's find the one over here first. So I'm going to go to the left, enter, or press this button, I think. And then it says upper bound, so I'm going to bound it on the right side. There it is. So it looks like it's going to be at 1.650. No. Let's just press enter. Press the middle button. Oh yeah, 1.650. So that's going to be one of our solutions. All right here. Okay, let's find another one. So menu, analyze graph, 0. Okay, so we're going to go over here. To the left of the 0. And then we go to the right of the 0. And it gets a little confusing because these things fall on top of each other. It's going to be negative 1.270. So there's our other 0. And one more. Lower bound. And negative 2.38. Negative 2.38. So if I was to sketch this, if I didn't know what it looked like, since my leading coefficient is positive, okay, that tells me, and see how the x cubed is positive, that tells me it's going to be going down on the left, okay, and it's going to be going up on the right. So if I was sketching this, I'd go up through my first 0, curve, come down through this 0, and then I would curve up through that one. So I could sketch my graph without a calculator. First of all, if I know the solutions, where they're located, and I know what it's going to do on the ends. And you can tell that by looking at the x cubed. If it's positive, it's going to be down on the left, up on the right. But we'll talk about that more later. I'll see you guys in class. Hope you're having a great weekend.